All right, today we're going to go over the ideal gas law. So, what does it mean to have an ideal gas? It's going to be should be the first question, right? So, when we're talking about an ideal gas, we're basically just talking about a gas that follows all the laws that we've already covered, such as Boyle's law, Charles' law, and so forth. Okay, so for example, Boyle's law states that if I have this gas here and I decrease the volume, there's going to be higher pressure, right? So if it's an ideal gas, it's going to follow those laws. Okay, if for example Charles' law says if I heat this up, there's going to be a greater pressure because things are going to move faster. So if it's not ideal gases, follow all the laws, all the properties of all the laws that we've gone over. Okay, so for example, if we cool it down, there'd be less pressure. It would still be a gas. It wouldn't necessarily turn into a liquid because it's an ideal gas. It follows all the conditions that we've talked about. Okay. So say we have a gas here. So let's go ahead and go over the things we can know about that gas. Well, I can measure, if I have a pressure gauge, right, I can measure the pressure inside that. So I can measure the pressure inside of this system, right? Usually we measure that in ATM, in atmospheres. I can measure the shape of this container, which is the volume of the gas, right? And we measure that in liters. Okay. I can know how many moles are in there. So I can know how many moles are in there. N represents number of moles. So number of moles of that gas. Okay. And I can know, I can take the temperature of this gas, so I can know the temperature. Okay. So I can know the temperature, which would be measured in. So whenever we're dealing with these problems, remember that is measured in Kelvin. Okay. All right. Let's make that a capital T. Should fix this here, capital T. Okay, so these are the variables we can understand. We know about a gas, right? The ideal gas law basically puts all the gas laws together and makes one simplified equation, which is PV equals nRT. Okay, pressure times volume is equal times N times R times temperature. What is R? That is what we call our gas constant. That is a constant number that scientists have done experiments to figure out what it is. So you don't need to know necessarily where it comes from. You just need to know that R, you just need to remember the value for R. So our R value is going to equal, R equals 0.0821, and then our units for this R are going to be liters times ATM times, or divided by Kelvin times mole. Okay, if you notice, all of these units are here, right? ATM is here, liters is here, moles is here, Kelvin is here. Okay, so keep in mind there are problems that you might be required to use a different R value. You might have the R value of, for example, R equals 8.31, and our units are liters times kilopascals, K times mole. Okay, so if you're given a problem, so how are these different? Well, first of all, the number is different, right? All the units are the same except pressure. So this is ATM, this is kilopascal. So if you are given a problem that gives you, rather than ATM, it gives you kilopascals, well, you're going to be using this number, 8.3, rather than this. Okay, or you can convert to ATM, but it's easier to just use this number. Okay. So that's our background information. So let's go ahead and solve some of these. Let's solve some of these problems. Yeah. Okay. So it's important that you read these problems carefully because you're always going to be given. Actually, let's go back. You're always going to be given. There's 5 variables here: 1, 2, 3, 4, 5. Right? You're always going to be given 4, at least 4, and you have to solve for 1. Okay, always. That's always going to be the case. But when it has to make sure that everything does have to be in these units here. Okay. All right. So let's look at this example. What is the pressure? So that's what I'm looking for. So I like to list so P equals V equals N. We can put R, even though that stays the same, T. Right. So what is my pressure? So that's what I'm looking for. Is required for 0.023 moles of nitrogen. So that's my number of moles. 0.023, right, of nitrogen gas in a 4.2 liter container. So that's my volume. My volume is 4.2 liters. My number of moles is this. Okay, at a temperature of 20 degrees Celsius. Well, that's not the units we want to use. The units we want to use are going to be Kelvin, right? So my temperature is going to be 273 plus 20. Plus 20 is going to give me 293 degrees Kelvin. Well, since we are using ATM, or actually in this problem, it just gives us the pressure. It doesn't give us whether it's ATM or kilopascal. So we can use either one. But if we use the first value, if we use the first value, we are going to be given the answer in ATM. If we use the second value, the answer is going to be in kilopascal. So let's just use the first value and let's get our answer in ATM. So our R value is just that first one, 0.821. Okay, and I won't put all the units for now. Okay, so this is my equation: P V equals N R T. Right. So if I want to get pressure by itself, then I need to move volume to that other side. In other words, I need to divide by V. I need to divide both sides by V. This cancels. This gives me pressure equals nRT divided by V. Okay. For this first problem, I'm going to go carefully through the units, and I'm going to show you why it cancels out. But usually I don't put the units. I just solve it, and then I put the unit at the end because the problem, if you did everything else right, you should get the correct units. Okay, so my pressure equals my number of moles, which is 0.023, right? Times R, we'll leave R at the end right now. So we'll just go times temperature right now. So times 293. And actually, I said I was going to put moles here. And I was going to put Kelvin because I'm going to put the units actually. And then in the bottom, I put volume, which is 4.2 liters. Okay, and I'm going to put the R value here because the R value I didn't put it. So we go times 0.0821. For the units, so remember the units are kind of odd in this, right? We have units on the top and units on the bottom. So the units are on the top. They're going to go here, L times ATM. And the units are on the bottom, well, they go in the bottom. Okay. You do actually switch these units, though, if the R value is in the bottom. But I wouldn't worry about that too much. Okay, so let's look at what happens. So the reason we end up with the units we want is because if these are across each other, they're going to cancel out. So Kelvin cancels out, moles cancel out, liters cancel out. Okay, so then I just do my math in my calculator. I just multiply. So we're going to go really slow through this first one, and then we'll go a little bit faster through the next ones, right? So I multiply the top. So I go 0.023 times 293 times 0.0821 equals, and I'm going to divide by 4.2. Okay? And my answer is, I'm just going to round to that second decimal, it's going to be 0.13. So my pressure equals 0.13. What are my units? Well, I was left with ATM, which makes sense because I was looking for pressure. it would be ATM. Okay, that would be my answer. All right, let's work through another problem, but we'll leave out the units because we'll go over why. Okay, so oxygen gas is collected at a pressure of this. So let's go ahead and start listing everything. P equals V equals N R T. Okay, so oxygen gas is collected at a pressure of 123 kilopascals. So 123 kilopascals. Okay, in a container which is 10 liters. So 10 liters is my volume. What temperature must be maintained on 0.5 moles? So that's okay. So my number of moles is 0.5 moles, right? My R, well, if I use kilopascal, then I'm going to use that second one, 8.31. Okay, so I'm going to use 8.31. We'll leave out the units for that. And then we're looking for temperature. Okay, so that's what we're looking for. All right, so now we go ahead and we do everything, right? So we know it's PV equals nRT. Well, I want to get temperature by itself, so I need to move this to the other side. Right now I'm multiplying, so I'm going to divide to get that to the other side. So I'm going to go divide by NR, divide by NR. This cancels out. Temperature equals PV divided by NR. Then we just plug everything in. So we go, I'm just going to plug in the numbers. Pressure is 123 times volume is 10 divided by my number of moles is 0.5 and my R is 18.31, right? So it's the top, so I go 123 times 10 divided by the bottom, which is 0.5 times 8.31. Close those brackets. Gives me 296. So my temperature equals 296. Well, remember this type of problem, when we use this value, the temperature is in Kelvin. So that's going to be in Kelvin. So I can leave it like this, but this problem wants it in Celsius. So if you want it in Celsius, you just do the opposite. Remember, usually we add 273. We'll take away 273, and that'll make it Celsius. Okay, but we're not going to, you can do that later. Okay, let's work through another example. So let's look at, I want to do a little bit more difficult. So number of moles. Okay. Also, if it ever gives you grams, you got to turn those grams into moles. Just keep that in mind. Okay. We'll do this problem down here. Okay. So it says calculate the volume of 1 mole of gas at STP. Well, P equals V equals N equals R and T, right? I list those variables and just make it a little bit, get organized. So my pressure, STP, what is STP? Well, remember, standard temperature and pressure, that's 1 atm. What's my standard temperature? That is 273 Kelvin. Volume, that is what I'm looking for. I have 1 mole. R constant, which one do I use? Well, if I have ATM, I use that top one, right? ATM. So I used 0.0821. All right, PV equals nRT. I want volume, so I take pressure, throw that on the other side. Cancel. Volume equals nRT divided by my pressure. Let's plug everything in and solve. I'm not going to put in any units. So I get moles is 1 times R, which is 0.0821 times my temperature, which is 273, divided by my pressure, which is 1. That's pretty easy, right? So then we just go 1 times 0.0821 times 273 equals, I get 22.4 divided by 1 would be the same answer. So my volume equals 22.4 1. Okay, so thinking back on volume, right? Well, which one has to do with volume? If I look at all my units, liters. Remember, liters is what we measure volume in. So my units would be liters. Okay. All right, I'm going to set one more up for you guys, and we'll go for. Actually, we'll solve this all the way through. So this next one, it's asking us. So let's read this whole problem through, because it looks like a big problem, but it's the same as every other problem. NR, actually forgot the V here, so we'll just put the V here. Okay, so this is the problem. How many moles of chlorine gas would occupy 35.5 liters? That's my volume, 35.5 liters, at a pressure of 100 kilopascal, 100 kilopascal. Okay, it says at a temperature of 100. So remember, temperature is going to be 100, but I got to turn that into Kelvin. So 273 gives me 373. Okay, and then N is what I'm looking for, my number of moles, because it said how many moles, right? R, well, I used kilopascal, so I need to use that second value now. I can't use that first one, so I'm using 8.31. So this number just depends on those units of the pressure. So number of moles, well, PV equals nRT. I want N, but I'm multiplying this here, so I got to move it to the other side. Divided by RT, divided by RT. This cancels. Number of moles equals PV divided by RT. Okay, so that means number of moles equals my pressure, which is 100, times my volume, which is 35.5. So 35.5 divided by my R value, which is 8.31, times the bottom, which is my temperature, 373 Kelvin. Okay, I put that in my calculator. I'm going to go 100 times 35.5 divided by the multiplication of the bottom times 737, close those brackets, gives me N equals 1.14 moles. Okay, and this is moles of chlorine gas, so I would have to turn this. If you put this answer, you would almost be there, but this tells you to calculate the number of grams. So we'd have to go back and remember stoichiometry. If we remember stoichiometry, we go to turn into grams, we have to convert, right? We go moles, and we put grams. We always go 1 mole. The molar mass of that's going to be around, so I'm going to say 35. And then you just go ahead and you do the math, and you would get your problem. Okay, so some problems will require you to do this last step where you turn it into grams. Some of them will leave it at moles. You just got to read the problem, and it'll let you know. Okay.